Hi, my name is Sean Hicks, and I did my presentation on software engineering and computer programming. It's from the Palma book, section 3-8, page 51. So what do software engineers do? They design and develop software, including applications, and some of these applications can be in the form of business applications, games, and operating systems. They use math analysis and programming to create these softwares, and some of the tasks are that they evaluate users' needs, and then they develop algorithms to satisfy these needs. So algorithms, you can think of them as a recipe, which is created by a chart, such as a tree diagram. And sometimes they code algorithms for the computer, but that's usually the computer programmer's job. There's two categories of engineers: applications engineers and systems engineers. The applications engineers design and construct applications and softwares using different programming languages. The common ones that I know of are C++, Java, and Python. There's also MATLAB and several others, C#, C. Systems engineers, on the other hand, build, maintain, and expand businesses' computer systems. They can set up networks and offer tech support, and they deal in system security. Computer programmers translate algorithms, so the systems engineer or computer engineer may create the algorithm, which is like the recipe, and the programmer will make the food using this recipe, so to speak. So they program the code that the computer can understand to satisfy the user's needs. So they can also update and fix bugs, and they can modify existing programs to make them better. There's something called CASE. It stands for Computer Assisted Software Engineering, and that could be that's beneficial to the industry, but it could be a hazard to or a threat to current computer programmers. So what CASE does is that it automatically generates much of the basic code for a program or using an algorithm, and it can lead computer programmers to have to learn systems engineering in order to be flexible in case their job is threatened by this automatic generating of code. There's also libraries of basic code, such as in C++, I know these two: IOMANIP, which stands for Input-Output Stream Manipulation, and CMath. CMath allows you to use math like absolute value and powers, like 2 to the third power, without writing your own code for it, because it's already written the code for that function. So these libraries allow you to code things without getting into the hard details of that code. The work environment for programmers and engineers usually sit at a desk, and a lot of them telecommute. You can work from home and you can communicate from home. The average number of work hours per week is 40, but some get more than 50 hours a week. For example, 15% of software engineers get more than 50 hours a week, and 11% of computer programmers get more than 50 hours a week. Some problems that deal with this job are health problems, such as eye strain, carpal tunnel syndrome, and back problems. Qualifications for software engineers usually need a bachelor's degree, and sometimes a master's degree is preferred. And for computer programmers, you usually need a bachelor's degree, but sometimes they'll accept a 2-year degree, but you'll need relative skills for the job that you're accepting. For advancement, you basically just need to keep up to date with technology. A lot of businesses will offer continuing education to keep you up to date with the technology. For education and training, software engineers, common majors for this job position would be computer science, software engineering, and math. For programming, common majors include computer science, math, and information systems. Some applications in the field of science and engineering: you'll need computer information science, math, engineering, and physical science. And in business, you need management information systems, business, strong programming skills. So employers, like I said earlier, will offer continued education a lot of the times, and sometimes they'll offer their own seminars in order to keep you updated with the new technology, so that you remain dependable, and so you don't have to go back to school and pay for yourself. There's also certification and qualifications. A lot of things that go on your resume, such as strong problem solving and analytical skills, are used in computer science. Creative, you have to be very creative because you'll have to be working on new programs a lot of the time. Communication skills, attention to detail, especially when you're multitasking, and business skills. So it might help to take some business classes. For advancement, computer programmers might become managers or software engineers, or program or systems analysts. Software engineers is kind of a step up from computer programming because they have to create the algorithms, and sometimes computer programmers also complete algorithms as well. I've done it before in some of my classes. For software engineers, their main advancement would be to become a manager and overlook the other software engineers. Employment in 2008 was 1.3 million jobs. Over here you see all the job titles right here and how many positions. So computer application software engineer had about 515,000, computer system software engineer 395,000, computer programmers 425,000, and self-employed about 50,000. So the job outlook is pretty positive. It's growing faster than the average in these fields, and it looks better for you if you have a bachelor's degree. For 2008 to the 2018 decade, there was a projected 21% increase in employment. For software engineers, you're looking at a 32% increase in employment with 295,000 or more new jobs. There's a high demand for an increase in networking because of the internet, web applications, mobile technology, and then data processing systems are getting more advanced. Also with software engineering, if you are good in that field, you're less likely to be offshored, because with computer science, you can write programs from anywhere, so this allows you to be offshored. You can go work in another country overseas, and you can still do the same thing, like telecommuting. But with computer programming, they're expecting a 3% decrease between that decade. So your best opportunity is if you have a bachelor's and if you have knowledge of multiple computer languages. So here's some earnings. With computer application software engineers, you can see over here that the median in 2008, this is all from 2008 for earnings, was 85,000 about. If you're a professional and commercial equipment and supplies merchant wholesaler, you can expect a median salary of 95,000. Software publishers, 87,000. Management and companies and enterprises, about 86,000. Computer systems design and related services, 85,000, and insurance carriers, 80,000. So the percent of computer application software engineers in the mid 50%, they're making a median annual earnings of 67 to 105,000, and a low 10% of 53,000 and below, and high 10% of 128,000 and above. So that's looking pretty good. In computer systems software engineering, the median was 93,000 about. And if you're in scientific research and development, you're looking at 103,000. Computer and peripheral equipment manufacturing, 101,000. Software publishers, 94,000. And then navigational measuring electromedical, 91,000. And computer systems design and related services, 92,000. The percent, mid 50%, is looking at 73 to 114,000. Low 10% is at 57,000, and high 10% is at 135,000. For computer programming, the median was about 70,000, with software publishers making the most at 82,000, and insurance carriers making the least at about 70,000. The mid 50% was from 53 to 90,000, and low 10%, 40,000, high 10%, 112,000, and more. So it's looking pretty good here. You can see the comparisons where it looks like the computer software systems engineers were making the most, or computer systems engineers were making the most, and then applications engineers, and then programmers. Some related occupations include actuaries, who analyze risk and financial consequences for companies, computer scientists, computer support specialists, system analysts, engineers, mathematicians, statisticians, operations research analysts, which I've been looking into personally, who help the management with decision making by using mathematical modeling. Some issues are the offshoring of computer programmers, which affects me because I enjoy computer programming, so I may have to learn more skills. And solutions are that the businesses may be able to help by the businesses can offer continued education. So there's this quote, when one door closes, another one opens, but I'm just thinking, how expensive will it be to open these other doors if you have to further your education constantly? So it might be important just to diversify my skills right now. And maybe if you're looking into computer programming, you might want to do the same. So that's it. Thank you.